Soldiers encounter ballistic and blunt impact events in every operating environment. Only the helmet stands between these threats and certain injury or death.
This is the Army's Enhanced Combat Helmet, commonly referred to as the ECH. This provides rifle protection for a specific threat. The prototype helmet has demonstrated a greater level of rifle protection for a more prevalent rifle threat at a reduced weight.
The current IHIPS system requires a secondary applique, weighing 40% more than the new helmet, to protect from rifle rounds.
Essentially, our main focus in science and technology is to reduce the physical burden imposed on soldiers with regards to their personal protective equipment.
During a ballistic event, we develop strain waves in the helmet. This is how we absorb energy from the projectile. Wrinkles will slow down these strain waves, and it'll reduce the rate of energy transfer into the helmet.
NSRDEC is using high-performance helmet materials, preforming manufacturing techniques, and multi-layer design concepts to maximize energy absorption while minimizing system weight.
When you take a two-dimensional sheet and you preform it into a compound curve, there's distortion happening within the fiber matrix. So to mitigate that issue, we create filler plies.
The Helmet Lab at NSRDEC has designed a novel helmet preforming device that works to form the deep compound shapes. The helmets are fabricated to precisely control material layup with no internal folds or wrinkles, greatly improving ballistic performance for lightweight helmet applications. NSRDEC is also developing new helmet ballistic and blunt impact test methods with improved data acquisition that is traceable to injury criteria.
We've recently developed a gas gun laboratory where we can accelerate projectiles that you might find in a real-world situation against armor systems that we're developing in our labs. So far we've found that using helium gas has been much more repeatable than using powder-accelerated projectiles. So it's very difficult to measure the exact amount of powder to repeatedly shoot something at the same velocity. It's important for us to be able to test at velocities more repeatably because it reduces the quantity of test samples that we need to impact to understand their ballistic resistance.
Traditionally, helmets have been designed and tested for fragmentation protection, yet blunt impact has become more prevalent in recent years, with soldiers coming back with concussive and traumatic brain injuries. Whereas current accelerometers only measure in vertical directions, NSRDEC is developing a new blunt impact test method that utilizes a 6-axis accelerometer to measure both linear and rotational acceleration.
For the behind helmet blunt trauma model, what we're trying to do is come up with a methodology that's more modular. It's based on force sensors that we can easily swap out. The heads are 3D printed. If we break one, we can just print out another one quickly.
Our goal is really to develop things from an applied science to that of an early initial technology insertion, thus allowing industry to come in and drive that to a point where we can have an operational capability.
The NSRDEC helmet provides increased protection at lighter weight, which will increase soldier survivability and as a result, increase soldier lethality.
Enhanced capability, reduced weight, survivability, protection, lethality.